Hi everyone. In this video we will see three ways to find nearest price and date using Excel formulas. So let's say we have this data here in which we have the date column and the price column which have the prices for each of the corresponding dates. Our task is that for each of the approximate prices here, we have to find out the nearest price which is present in this price column. We will see each of the three methods step by step, but before that let's define that what do we mean by nearest price. So let's say we have approximate price as 218 here and we have different prices here. If we see, let's say the difference of 218 from 231.95, the difference is negative 13.95. If we see, let's say difference of 218 from, let's say 214.10. If we see this, the difference is 3.90. If we, let's say, see difference of 218 from 177.30, the difference is 40.70, right? Similarly, let's say if we see the difference of 218 from 239.05, the difference is negative 21.05. So these are the different differences here that we have. Now which difference do we have to select? We have to select the difference which is the minimum in this list here, right? So let's say if we try to find out the minimum here from this list, if we use minimum function here, we will get negative 21.05. Now this is misleading. Why this is misleading? Because we have to consider the absolute differences. We don't have to consider the direction. The value which we are trying to look up, it could either be greater than 218 or it could be less than this approximate price 218. Right? The value could be greater than or less than 218. But its distance should be minimum. Its distance should be lowest. So if we see this list, in absolute terms, the minimum distance, the lowest distance is 3.9. So we have to consider the absolute differences from this list. We don't have to consider these differences, but we have to transform them so that they all have the same direction, either in the negative side or in the positive side, but their sign should be same, and then we could make the comparisons. So let's say if we change this to 13.95. So if we, let's say, make this 13.95, right? This will be as it is 3.9. This will be 40.70, 40.7, and this will be, let's say, we will convert this number to a positive number. So 21.05. If we, let's say, have this series and then we try to find out the minimum value from this list here, then we will get 3.9 here. And this is what we are trying to extract, the minimum distance in absolute terms. And then we will extract the corresponding price here, right? So if we see, this should be a result. 214 should be a result if we are considering these differences. Similarly, what we will do, we will find out the difference of each of the prices present in this list from 218. Then we will convert them all to a similar sign so that all the differences have a similar sign. Here, let's say we are assuming that all the differences have a positive sign, and then we will find out the negative value, right? Let's say if we make all the differences negative, idea is that all the differences should be of the same sign, either positive or negative, it doesn't matter, but the operations will change accordingly. So let's say if we make all the differences negative, so negative of each of the numbers here, and then if we try to extract the minimum value from this list, we will get negative 40.70, which is again wrong here. What we will have to do, we will have to use max function here. So if we extract maximum of these values here, we will get again negative of 3.9. We only have to focus on 3.9, so we are getting that result. Again, it is present on the second position, so accordingly we will extract the price at the second position here, right? So that is our target. And how can we convert the differences to same sign? We will explore different ways here. So, and now what we will do, we will start with the actual working for method 1. So we will delete this, and as our first step, what we will do, from each of the prices in this price column, we will subtract, let's say, 218. First of all, we will do all the calculations, all the computations for this single price 218. Then we will apply the same for all these approximate prices. So what we will do as our first step, from this price column, from each of the values here, we will subtract 218. And also one thing that we could do the opposite as well. So here from this price we are subtracting the approximate price, but we could do the opposite as well, that from the approximate price we could subtract these prices as well, because at the end we are neutralizing the differences, so the signs will be gone. It doesn't matter that on which side we have the difference, right? So we could do that way as well. If we press enter, we get these differences, and we could see here that some differences are positive and some are negative. Now our next task is that we have to neutralize the signs. So we have to remove them. We have to either make them all negative or make them all positive. The signs should be similar. So the easiest way to do that in Excel is using absolute function. Absolute function applies the absolute operator that we study in mathematics. So it makes all the negative numbers as well positive. So if we use that in Excel, equals to ABS, ABS for absolute, its description says that it returns the absolute value of a number without its sign. And that is also we are trying to achieve. So we will use this. And as our number input, we will select this array of differences, close the bracket, press enter, and we get this as a result. So if we see, all the positive numbers are as it is, but the negative numbers are converted to positive numbers. And this is what we are trying to achieve, that all the numbers have the same sign. And this is the result that we have here. Now our next task is to find out the minimum absolute difference. So we will use equals to min of these neutralized differences. So this is the minimum difference, 0.35. And just by looking at this difference, we right now we cannot say that this difference is on the upside or on the downside. So the final value could either be 218 plus 0.35 or 218 minus 0.35. But we cannot assure anything for now. We will have to look up for this difference in this array and then return the corresponding price here, right? So let me name this as well. So this is the difference, and this is the neutralized differences. Neutralized differences. So we have removed the signs from here. That's why they are neutralized. So 0.35, and then what we will have to do, we will have to look up. So for looking up, we can use XLOOKUP function. We have to look up for this minimum difference. Where do we have to look up? So if we manually look up for 0.35, if we try to locate that, this is the difference that we have. This is the minimum difference, minimum absolute difference. And if we see, we have 218.35 here, right? So that means that our difference was on the upside, and we have to return this value in return, 218.35 in return. We have to get that back. So what we can do, we can use XLOOKUP now. XLOOKUP, look up for this difference. Where do we have to look up? We have to look up here and get in return the corresponding price here. If we press enter, we get the desired result, that is 218.35. This is on the upside. Let's say we try another value, and also let me show you the other way around, that is approximate price minus the prices. If we, let's say, see this for 233, then we get 0.25 as the difference. Again, just by looking at the difference, neutralized difference, we cannot say that this is on the upside or on the downside. But if we see the final result here, 232.75, this is less than 233. So the final result could either be greater than or less than approximate price, but its distance will be lowest among all the other differences. That is the goal here. Now let me also show you that the result will be same if we do the other way around. So E7, that is approximate price minus each of these prices, if we do this, then also our result will be unchanged, because at the end we are making the signs similar here. And let's say if we convert these differences, all these differences to negative numbers, we have these negative differences, and then instead of minimum function, we can use max function here. If we use max function, then also we are getting the correct result here. So the crux is that the differences should be of the similar sign. It doesn't matter that we make them all positive or make them all negative. And what are the alternative ways of making the signs similar? Let's also discuss that. So these were the differences. And if we have to make all the signs similar, one way could be that we take the square of these numbers. So if we use power function, or we could directly do that. So if we, let's say, raise all these numbers to power 2, raise these numbers to power 2, We have the squares of these differences, and when we get the square root of these numbers, we will get the same result here. So these differences and these differences will be same. These are negative numbers, so we could remove the negative sign from here. That was just for illustration, that we could do anything. The only goal is that we have to make the signs similar for each of the differences, and instead of using max, we can use minimum function, and we got this result. So if we see neutralized differences here and here, they are same. So for negative numbers as well, they are same, because a square converts the number to a positive number, and then when we again do the square root, we are getting the exact same result. Even only the square will also do the work for us. So if we, let's say, find out the power 2 of each of the numbers here, and we find out the minimum value here, we get this result. And when we try to look up this minimum value in here, comma, return the price, corresponding price, and if we see the result, this is exactly same. So again, this could be another way, but I am not counting this as method 2. Method 2 is different. So if we see this way, there could be 4 different methods as well. So this could also be one way, right? This could also be one way to make the signs similar. So square root, if we try to find a square root as well, then also the result will stay the same. So we have this result here. This is another way of neutralizing the signs here. I can remove this. And another way could be using sine function. So let's say if we use sine function here, and we try to find out the sign of these differences. So what does sine function do? That for positive numbers, it will return 1, right? That their sign is positive, so it will return 1, positive 1. But if the number is negative, if we have a negative number, then it will return negative 1. So we have this in result. If we see the utility of sine function here, we know that if when we multiply two positive numbers, we get a positive number in return. And when we multiply two negative numbers, then also we get a positive number in return. So if we multiply, let's say 4.35 with 1, we will get in return 4.35. If we multiply minus 6.05 with minus 1, we will get 6.05 positive number in return. Right. So that is also something we can try out. So if we multiply the signs with these differences, we will get the result, and this is the result that we have. Again, these all are neutralized. The signs are removed here. They all are positive numbers now. So these are alternative ways to neutralize the differences here. We will stick with absolute function, but these are again alternatives. So this is the method 1, and now we will try to wrap all the calculations in a single function. So if we see this final result, we have these three inputs: K5, J5 hash, and table 1 price. So this is the user input. So we will keep this untouched. We will replace these two inputs with the respective calculations. So we will replace, let's say, K5 with its computation. So we will copy this, and we will replace K5 with that. And now we have two intermediate steps, that is J5 hash. And since we are using it twice here in a single formula, what we can do, we can use let function to further optimize this, so that we could reuse J5 hash multiple times. So we will use let function. Let a be, let's say, J5 hash, comma, we can replace this J5 hash with a, and this as well with a. And we can close the bracket, press enter, and we have this result. So we can remove K because we have already defined that. Then we will go to J, and we will copy this formula, delete this, and in place of J5 hash, we will replace that. Right, now we have reference to I5 hash. So we will again go here, copy this, and come here, replace that I5 hash with that formula, press enter, and we have this result. Now we are only reduced to user input. So E7 will be a user input, this will be a user input, and this will be a user input as well. So this is the formula that we have, final formula. And now we can copy this. We will come here, paste that, And let's say we do this for 218 now. So we are getting this result. Now we wish to do this for each of the values here in this list and get the result as a dynamic array. So for that we can use map function. So map function will apply this operation on each of the values in the array that we will select. So let's say we select this array, comma, we will write the lambda here. And let's say we denote each of the prices here by P, and we are using that price here, right? So we will replace this E6 by P here. Then we will close the brackets at the end and press enter. We got the result for each of the approximate prices here. We have the result here. We have the nearest prices here, right? We have the nearest prices, and similar way we could find dates as well. So we will paste that. And what we can do that instead of returning the price column in XLOOKUP, we can return the date column. So we will select that date column, press enter, and we have the corresponding dates as well. On 15 February 2023, we had this price 218.35, which is the nearest price to 218 here. So this is the result that we have. Now we will move on to method 2. And in each of the three methods, these two steps will be same. That is, we will have to find out the difference and neutralize the differences. So these are the differences, right? If we, let's say, change that back to 218, so these are the differences, and for neutralizing the differences we can use absolute function. So absolute and absolute of these differences. So these two steps will be same for method 2 as well. Now the difference is in the next step, so we could remove this because we have already used that here. Now let's see the method 2. Now the logic that we are going to use in method 2 is that once we have neutralized the differences, we know that none of the values will be less than 0. The values here can be equal to or greater than 0, but none of them will be less than 0 because we have removed the negative numbers here. We have converted them to positive numbers. So using that logic, what we will do, we will try to look up for 0 here. So if we look up for 0 here, 0 can be present in this array or it cannot be present in this array. If 0 is present in this array, that means that this exact value is present here in this price range. This exact 218 is present in this price range. So let's say if I change this value to 218, right? And if we see the corresponding difference here, we get 0 here. We get 0 here. And also here as well, the nearest price is 218, right? So if exactly 0 is present, we will return that. 0 difference means that that exact price, approximate price is present in the price list. But if 0 is not present here, what we will try to do, we will try to find out the next larger value than 0, because difference either could be 0, neutralized difference either could be 0, or that would be greater than 0. It cannot be less than 0. So we will try to look up a value that is just next largest value to 0, right? That is the logic that we are going to use. So if we see here, we have many values. Again, they all are greater than 0. But if we see here, 0.35, this is the next largest value to 0. If we try to, let's say, sort this range, if we use sort function and we sort this differences, neutralized differences, they are sorted in ascending order. And if we see here, this is the smallest difference. 0.35 is the smallest difference that we have. Neutralized difference again. And this is just next largest value to 0 present in this range, right? If we, let's say, change this to 218, and if we see 0 is on top, so we will return 0, right? We will return the price corresponding to 0 here. But since we don't have 0 here in this differences, we will return the value that is just next largest value to 0 here, which is 0.35. So we will return this. And for that, we have another parameter in XLOOKUP which we can use. So we can delete this. And what we will do, we will use XLOOKUP. We will look up for 0 because none of the values are less than 0. We can easily look up for 0, comma. Where do we have to look up? We have to look up here in the neutralized differences. What do we have to get in return? We have to get prices in return, comma. If not found, we can omit this. Match mode is that if 0 is not found, then return the next larger item than 0. searches for an exact match. If not found, searches for the next larger item, and next larger item, just next larger item, then 0 is 0.35. So it will return the price corresponding to 0.35. So we will select this, close the bracket, press enter, and we got the correct result here, 218.35, and the result that we got from method 1 is also 218.35. If we see for, let's say, another approximate price 233, we are getting the same result, 232 here as well and 232 here as well, 232.75 to be precise. So this is the same result that we are getting. We can use this logic as well. And similarly, again, as we discussed earlier, signs doesn't matter. Only thing that matter is the signs should be same across all the differences. So if we, let's say, change this to negative, so all the differences are negative here, that means that none of the values are greater than 0 here. All of the values can be either 0 or they can be less than 0, but they cannot be greater than 0. And that's why we are getting any error, because we are not able to find a value which is just which is equal to 0 or just next larger value to 0, which is greater than 0. So what we will have to do, we will have to use another argument here, that is -1, exact match or next smaller item. So just next smaller item than 0, because all of them are negative. So we will use this -1 here, -1, and we got this as a result, that is 232.75, right? And this is again the same result that we got here and earlier as well. So we can do this as well. Let's proceed with negative signs here. uh, so we have this result here, and now let's try to wrap all these calculations in a single formula. So we have this reference to J5 hash. We will go here, we will copy this, come here, replace that J5 hash with the formula, and we have reference to I5 hash now. So we will copy this formula now, come here and replace this I5 hash with that formula. Now we are down to only user input, so we will not further make any replacements. Let's press enter. We have this result. Let's copy this and let's apply that here in method 2, and let's change our value approximate price to this price, press enter. We have this result. Now let's try to do this for each of the values here. For that we will use map function. We can use by row as well, so let's use by row. By row, for each of the rows in this array, since this array contains only a single column, we can use by row here. So for each of the rows in this array, what do we have to do? We will have to apply first of all lambda function, and let's say we denote each of the rows in this array by p. For each of the row values, what we have to do, we have to apply this operation, and we will replace this E15 because we are using that as approximate price input. So we will replace that by p, and we will close the brackets here, press enter, and we got the same result here. And if we, let's say, remove the negative sign and we use +1 here, then also we are getting the same result here, right? We could keep that negative sign as well, just for reference that signs doesn't matter. Only thing that matters is signs should be similar. So we can use that as well. And now in similar way, we can find out dates as well. Let's copy this. Let's come here. Let's paste that. And instead of returning price column in XLOOKUP, we can return dates as well. Press enter and we have this result here. We are returning dates here. So this was method 2 for us. Now let's proceed with method 3, and let's see what do we have here. Again, the first two steps will be same. That is, we have to find out the differences. Then we have to neutralize the differences. And let's say we make these differences as positive differences. We have this result here. We can remove this now. This was method 2. And in the method 3, what we can do, we can sort the neutralized differences and then accordingly sort the prices as well and return the first price. So that will be the idea here. So what we can do, if we, let's say, sort only the differences, if we sort only the differences, we get this in return. So we have 0.25, but we have to return the corresponding price as well. So how can we do that? Sort function will directly not work here. Better alternative is that we can use sort by function. So what we can do, we can use sort by function. Sort by, and we have to sort which array? We have to sort this array that is price, because we are trying to extract this, comma, by which array? Which array do we have to sort? So we have to sort this array, and what sort by will do, it will sort them correspondingly. So it will sort neutralize differences, and it will return the corresponding price column, right? And our sort array is ascending order. Since these differences are positive, so we are sorting in ascending order. Let's press enter. We get this in return, and the first price that we have here is 232.75, which is again exactly same here. So we are trying to extract this first price. So we can use index function, and from this result, let's extract the first row and first column. We have this result here. And if we had, let's say, negative differences for each of the differences here, we are getting this result. But what we will have to do, we have to sort in descending order. So then we will get the correct result here, right? We can do that here. Now let's try to apply this function for each of the approximate prices in method 3. Let's paste that here, and let's make the replacements here. So J5 hash reference. So we will copy this. We will come here, replace J5 hash with this, and I5. So we will copy this and replace I5 hash with that, and we will place that here. Press enter. We have this result. Now we have to do that for all of the values here. So we can use map function. Map this array, values in this array, comma, lambda, and let's say we denote each of the values, each of the prices by P, and replace this E24 reference by P. Close the brackets, press enter, and we have this result. Now let's copy this, apply that same thing for date as well. So we can replace the array which we are sorting, we can replace that by date column here. Let's paste that here, and we got this result here. So we have the results from all the three approaches here, and that is it for this video. I hope you like all the three approaches and all the logics and functions that we have discussed. Please drop your suggestions and feedback in the comment section. I hope you like this video. Thank you so much for watching, and stay tuned for more such videos. Thank you.